Okay, just like we ended the last page, at the beginning of this page, it's a couple of practice problems that are just writing in an equivalent expression. It's not going to be on the test. It's just good brain practice for you. So this time says to deconstruct each exponent using the add, multiply, subtract rules, etc. So see how these two are adding. So we're going to break this apart into two same bases, and then we're going to make the negative x on this side and the positive 2 on this side, and there you go. That's deconstructing the add rule. Here we have 1/8 root of 6 to the x. That's one way that we could rewrite an equivalent expression, because a fractional exponent could be rewritten as a radical. And last is the add rule again. So two big bases of 2. Do you see how we could have the 5x here and the positive 1 there, or no number, invisible 1 can be invisible. So that's it, not on the test, but good practice for your brains. Here's something that may be on the test. Okay, word problem with a percent multiplier. We're studying growth of the culture of bacteria, and it's growing by 7% each day. She noted that there were 450 bacteria in the culture to start. So this is going to be a time zero function. It doesn't say like in the first week, in the first year, in the first whatever. Now there is one little typo here, if you could go fix it. This hours right here, everything's about days. So let's change that to days right there. So sorry about that typo. Please change it to days. Okay, writing a recursive sorry, this is not an F. They're telling us to use P of T as our function name. So we're going to say P of 0. We're starting with 450 bacteria. And then P of T is equal to P of T minus 1. Now, what the heck do I use as my multiplier if it's growing by 7% each day? So anytime you see a percent means I need to get the multiplier. And you guys in Math 1 should have been exposed to a little percent multiplier formula called 100 plus R. So 100 plus 7 becomes 107, and then we convert to a decimal by moving the decimal twice to the left. So 1.07 is my multiplier. What are kids going to do wrong on this one on the test? Kids might think they're just supposed to take this 7% and plug it in right here, when in fact this multiplier comes from doing this little formula. Don't forget about the 100 plus R formula. Okay, here comes my explicit. P of T equals, begins with 450 bacteria times our multiplier of 1.07 each time to the power of T, because it's T minus times 0, not a T minus 1. And by the way, this thing I'm writing is a little lowercase italicized t. If you want to make your T a little bit more straight, that's fine. Now we're just plugging into this formula. You need a big calculator. It says, what about in 2.5 days? So P of 2.5 is equal to 450 times 1.07 to the power of 2.5. You're going to plug that into your calculator, and we're going to check your answers tomorrow. The next one says 6 days from now. So P of 6 begins at 450 times 1.07 to the power of 6. And you're going to plug that in so we can check it for tomorrow. And last is P of 10 days ago, negative 10. 450 times 1.07 to the power of negative 10. So we've got one decimal exponent, we've got one negative exponent, and we've got one plain 6 exponent. You're going to get me those 3 answers so we can go over them tomorrow in class. I'm going to ask to see your worksheets. Okay, by the way, when you're plugging these into a big calculator, there's a little up arrow for the power exponent. All right, last, they're having us do a row of factoring. So you choose your method, but most of you prefer the x. What times what is 49 and adds up to negative 14? 7 times 7, they both need to be negative. When it says to factor, we literally, this is a y. We literally stop here, y minus 7, done. We don't set it equal to 0. We don't solve. We just factor. Do not pass go, do not collect 200, da-da-da-da-da. So the next one is Gcf factoring. Notice there's not three things. Oh, by the way, could this one be rewritten like this? Yes, it's a perfect square. But either way works. All right, this one's Gcf. What divides into 27 and 45? Do you see the -9 can go in? And there's also an extra c. So a -9c is my greatest common factor. What would be left over? -9 times what to give me 27? You got it. There'd be a 3c there. And -9 times what? And then we double check to see if our work is correct by multiplying this. So -27c squared, -45c, check, I like it. All right, last one, I'm going to try the x on. What times what is -60? I'm thinking 15 and 4 won't work. 20 and 3. Yep, that's it. So this one's going to be h minus 20 and h plus 3. When it says factor, I just stop there with the factors. I do not set it equal to 0. I do not solve. I do not do anything else. Now, what if you're having trouble coming up with the 20 and 3? This is where I wanted you to make a list of factors. So off to the side, you would go 1 times what? 2 times what? 3 times what? 4 times what? 5 times what? 6 times what? Etc., etc., etc. So you make this list and then you see which one subtracts. Now, some people could have been faked out by the 5 and the 12, but the signs don't work for the 5 and the 12. It has to be the 20 and the 3. All right, last, solve by factoring and using the zero product properties. So it's telling you specifically which one to use on this. It's saying to solve by factoring. So what times what makes -24? Pause the video and try all these, and then let's see how you do. I just got 2 real roots, -3 and 8. And again, I just got 2 real roots. Let's double check that I like these factors. 4w squared plus 22, check. Solve each piece. This last one is a fraction. I still got 2 real roots, but the last one is a fraction.